We are Group 2 and will be presenting the key differences between traditional pharma and digital pharma with regards to freedom to operate and differentiation center. As we can see from the slide, traditional pharma and digital pharma have very different system boundaries. Traditional pharma has a clear and simple product structure, whereas technology is basically the product which is covered by patents, which leads to clearly defined system boundaries for FTO analysis. In contrast, digital pharma involves a complex system, as you can see from the interface. This leads to a very fuzzy system boundary. The business model determines the required technologies, which is covering not just pharmaceutical products and IP classes, but it spans medical devices, software, AI, algorithms, data processing, insurance, etc. So there are many interconnected components here. There is a patient platform, physician platform, insurance platform, the management system, which covers patient profile, drug profile, the core system, which involves sensors, artificial devices, electronic components. Then there's historical data, there are simulation models, there are optimization models. So, which means that the IP classes are related not just to pharmaceutical industries, but this is beyond, it spans it covers a wide range of IP classes, which could be related to electrical components or data processing. So this leads IP mapping very complex process, and the more the digital systems are involved, the components are involved, the fuzzier the IP mapping becomes, which brings in non-traditional business players in the core system. So with that, we move on to the next slide, please.
When we check the relevancy of the patent types for the traditional pharma and digital pharma, we saw that patent type 2 is a classical example for the traditional pharma because it's about super fast acting insulin compositions. When it goes to the digitalization, we can talk about the sensors, control systems, and data management system. So patent type 3 can be assigned in a core system as a sensor, and patent type 1 is about a control system which can cover the core system. And patent type 4 is about data management system, which can cover the management system and core system as well. We can say that it's a digital ecosystem. Next slide, please.
Yeah, so this slide allows comparing the complexity of carrying a FTO search in the traditional pharma and in the digital pharma. So we have four types of patent. The patent type 2 for composition. And if you want to do a FTO search for a composition, we are restricted to a small number of classes. And we see in the type 3, type 1, and type 4, for example, for the sensor and for the control loop for the pump, that the number of class is larger and it is different classes, A or G. And in the last type, data management system, then the number of IP class is even broader. Also, another aspect is the type of applicants. So for the composition, the applicants will be well-known in the field applicants. And in the type 3 and 1, we have different actors coming in. And in the last type, an even broader range of applicants like IBM, Microsoft, Google. And on the last, at the end of the column, very interesting, the evolution of the number of applications. So in the traditional pharma, a small number of patent applications, which is decreasing. In the second and third column, number not too high, but increasing number of patent application. And in the last column, a very high number of patent application that need to be considered as increasing. So the conclusions is the more digital system components are, and the more they relate to data processing and data management, the fuzzier the IPC mapping becomes. And at the same time, the number of relevant patent applications and the number of patent owners outside the industry are increasing. To next slide, please.
Okay, have it done it in mind, and as we remember that the traditional pharma is using a protection center, the potential FTO process, it's really to understand the product, so the molecule, to find the correct attribute and element. Then we need to select, of course, and see the coverage and the coverage and the territories we need to search for. And because these molecules, we need to be sure to have the correct database, mainly the structured database, to find the correct at the correct place. And as is the technology is the product, we need to find the keywords and classification is mainly on the application of the molecule. And then based on the classification and on the keywords, we are creating the search strategy, so the strings to find the correct patent application. Then we do the search, and based on the search, we evaluate the research. And that is for the traditional pharma. And now Daria will explain you for the digital pharma and the Differentiation Center. I let the floor to Daria.
Thank you, Adrien. So in this plot, we see the further development of the FTO analysis now for the digital pharma. You can see in the darker shade of blue the additional process steps that are added to the traditional flow chart of the FTO analysis. At this point, we should keep in mind that here we're analyzing not a single molecule, single patent, single product, but the complex structure of the product offering we're trying to push on the market. Therefore, most probably our FTO process would not be complete. So we should proceed with this in mind and prioritize the selected attributes to run the deeper comprehensive search on them. If we continue further down by the pipeline, we see that there is the absence of the databases. So at this point, they rather unexistent or fluctuate highly with the information in them. As an example, here are the open source licenses for the dependencies. We go further right and we see that it's not only the application-oriented classification can be used, but also the functional one. But as we have seen on the slide presented by Eric, the IPC classes become very more various and numerous as we proceed to the digitalized economy. Therefore, at some point, perhaps IPC would not serve the purpose of the analysis, and one should focus more on the Boolean queries. At the end of the pipeline, we read that we should match the search results with the characteristic structure, and that this match is often unclear given the technical complexity. Indeed, seeing the whole space and the volume of the process we are trying to do the FTO for, this seems quite relevant. Thank you.
Okay, and the last one. So many differences have been presented between both traditional pharma industry and digital pharma industry. So now let's just shortly dive into the freedom of operate in relation to both. The development processes for business models and products differ in both industries. So they differ from traditional pharma to digital pharma industry, especially in regarding to the development periods, which have then impact on the performance of the freedom to operate. On this slide, you can see the comparison and the differences between the timeline of the development processes and the implications these differences have on the performance of the FTO, so freedom to operate analysis. In traditional pharma, the products are introduced on the market and are introduced as unchanged, so permanent, and the FTO analysis is performed at the end of the product development, but before the market launch, meaning that the FTO analysis is performed as a snapshot. Whereas in the digital pharma industry, we can see that the FTO is performed as a continuous support process. The reason for that is the fact that the digital business model is continuously being developed, expanded, and or modified. So the FTO analysis is being established, therefore. So this is the end, and thank you.